Alright, this video is for my dad. Hi Dad, Merry Christmas. And Tara, my assistant. Tara, you want to show yourself? Say hi to the camera.
Hi.
And for Christmas we're giving Dad the Initiator rocket. This is the box it'll come in. But I'll keep this video posted for other people who may want to build the Initiator, but build it for CTI engines. So we're going to do a conversion to this kit so that it accepts CTI and not specific to AeroTech. It also enables the rocket to use larger engine sizes, so you can go from a mid-size launch to actually into a level 1 level. So this is the kit, comes in this box here, and when you assemble it, the kit will look like this. This is the first one that we built. Unfortunately, we had a little bit of an accident where we didn't calculate the thrust to weight ratio correctly, and so the estimated time for the ejection charge to go off was delayed, so the rocket had already started coming down pretty quickly when the ejection charge did come off. And you can see what happens when a rocket is traveling 50 mile/hour or plus. When it pulls the parachute out, it's what you call zippering, and basically zipper the whole side of the rocket. So we've since cut the kit in half. We will be repairing this, but I'll use this one for explanation purposes going forward. But this is what the rocket will look like, and it's pretty much identical to the kit and the modifications we'll talk about today. What we've done since then is use the same dimensions of the Initiator, but this is a fully fiberglass kit, custom made by myself. So the inside is a fiberglass tube, outside is a fiberglass tube. The only pieces that we're using from the kit is the actual plastic fins and the nose cone. But in the case of the plastic pins, we've done a full fiberglass tip to tip with heavy epoxy, and you can see there's no seams, and you can see how the ends are rounded. But I'll use this rocket to demonstrate some other modifications we're going to make to the kit. So starting out, when you get the kit, some supplies that I recommend to make it easy. First of all, the adhesive that you're going to use on the kit. For everything on the kit, with the exception of the engine retention ring, you need to use a 5-minute up to 30-minute epoxy. I recommend 5 minutes because most everything, once you set it up, you want it to dry pretty quick. This is Loctite epoxy. You need to use an epoxy that has a hardener and a resin, because the strength of those epoxies are what you need for the kind of stresses the rocket goes through. So Loctite can be found in Lowe's and other stores, but if you have any other name brand that you like, preferably 5-minute, make sure it's a mixable epoxy. As far as the engine retention ring, we use JB Weld because it's at the point of the nozzle in the engine, so it does get hot. So we use JB Weld to make that attachment there. Another thing, I use wood filler glue from Elmer's. It's kind of a pasty appearance. I use this to fill in any cracks or any gaps during the painting process, and also the pre-assembly, which I'll explain shortly. Works very well, dries pretty quick, and you can sand it. Blue tape, you can't have enough of this. You'll use this during the assembly. You can use this to secure your engine igniters, wires at the launch pads. It's good enough to hold things, but not so much so when the rocket, when you want it to tear away, it does. So get some blue tape. The painting process, I like to use a sandable primer. All three of these have worked well. They're all by Rust-Oleum. They're slightly different. One, you have the 2-in-1, goes on a little thicker, fills more cracks. Even in Lowe's, if you can only find the auto primer, that's fine too. Sandable primer is good. I like to stay with the grays. This is, however, is an off-white or light gray, but any one of these will work. So let's start with the assembly. I took the instructions that come with the kit. I will be sending this out, Dad, to you in the email so that you'll have the exact same instructions I have. But I've marked out all the steps that don't apply with the modifications that we have, so we'll go through that here shortly. So there are some pieces to the kit that you want to eliminate. When you open up the kit, you're going to have this mesh, and there's a plastic baffle that's listed up here in the parts list. I've tried to use that before, but it tends to absorb too much of the ejection charge, and I've had a couple of times the parachute doesn't come out. So you eliminate this and the plastic baffle. We also are going to make this engine tube where it will accept a CTI engine. So all the first steps, they're talking about putting things inside the motor tube to adapt to AeroTech's engines. We don't want to put any of those in. So a lot of the first instructions have been deleted. So those parts, you're just not going to use it. And the main one is the engine hook. The engine hook is explained throughout the instructions. We've deleted that. And the idea is in the kit you have your engine tube, and it goes here per the instructions and clips the end of the engine, but the kind of engines we're using don't need this, so we're going to get rid of this and use the AeroPack. This is actually too big, but it's the only one I had. But the AeroPack actually will glue onto the end of the tube, and that's what holds the engine in, so that replaces this pin here. The other thing that you'll get, part of your package, is this what we call this parachute protector. It's basically a fire retardant material, and we're going to put that actually on the parachute where the parachute connects to the injection cord, and this will actually substitute for wadding, so it'll protect your parachute, and I'll show that in a later video how to put that on. The other pieces that are unique is this is the CTI engine casing. This is a 3-grain engine casing, so all your engines will go into this. This will hold up to 3 grains. This is the retention ring at the back. So you'll get this in the kit. You have 2 spacers. So if you're running a 3-grain, you wouldn't have any spacers. If you're running a 2-grain, you would put 1 spacer in. If you're running a single grain, you'd put both. The idea is you want the engine, when you put the engine in, to butt up to a hard surface. Then you would screw this on. So I'll go into more details of an engine load. What comes with the kit is the ejection delay that you use to actually drill out part of the delay burn, and this is how much seconds you're reducing from the ejection, so I'll definitely go over that. This is an engine casing. The igniter's taped to the outside. This is a White Thunder. This is the lowest, smallest CTI engine you can use on this kit and still meet the thrust to weight ratio. So I'll actually do a demonstration while I set this up, but you'll be getting 2 of these. This will actually put this rocket up about 700 feet, so this will be your first engine use, so I'll go in greater detail on how to do that. Okay, so now I'll go over details on the actual construction of the rocket. Okay, before we start construction, I would note that it's a good idea to keep the box. The box actually has some perforated areas on the back, and the idea is when you actually assemble it, it actually serves as a kind of a test stand where you actually can sit the rocket on and do maintenance or load engines. So it's nice to have this out in the field with it set up so it could actually be a rocket mount. Even some of the smaller rockets can sit on this, so it's a good thing to have in the field to hold it up. So step one in my process, which is not highlighted in the instructions, is when you open it up, you're going to have the outside exterior tube, you're going to have the engine tube, and you're going to have the fins, and you're going to have the nose cone section. I would take all three of those, or all four, four sets of pieces, and take a 60 to 80 grit sandpaper and sand everything. With the tubes, you want to get rid of this kind of glossy feel. You just want to rough it up. The motor tubes, you're roughing them up so that the adhesive will stick better. Same way with the fins and the nose cone, you want to rough that up just so the primer and paint and the glue sticks to the fin. So that's step one. Just take everything out and sand it up. Step two is then take just the engine body tube and get you some of the wood filler, and take the wood filler paste and put it in like a paper cup, and you add water to the amount that's in the paper cup, and you may have to add some more paste, but anyway, you keep adding paste water until you get almost like a mayonnaise to ketchup viscosity. You want it to be kind of more of a liquid form than what it comes in the case currently. Let's see if I can get this open. So you can see here it's kind of more of a paste here, but you want to get it where ultimately you could brush it on with a brush. So if you've got like an old smaller brush, this is water soluble, so it comes out of the brush pretty well. But the idea is on these seams, you want to brush over a pretty big area. I brush on almost a ½ inch all the way around this tube on the seam. The idea is you want to get the wood filler into this crack. In this case, this one actually a pretty good tube. The crack is not that bad. Some of them I've seen the crack can be almost up to 1/8 of an inch, but the idea is you want to, brush on a fair amount. It should be, a noticeable bump of putty on there as you brush it on and go all the way around. And basically then take this tube and set it aside and just let it dry. It dries pretty quick, but in my situation, you're not going to use this tube for a while, so just let it dry overnight. What might make your life easier too, you can see they've already pre-cut where the fins go. So before you put the putty, you might take a hobby knife or X-Acto knife, go ahead and cut those out, and maybe take a file or something and just square them up. Make sure they're nice and clean openings, and then that way when you put the putty, if the seam goes right across, you can stop it. You don't have to put any putty anywhere in the section where the fins are. But once you have the wood filler painted on there and you've taken the excess pieces where the fins go, set the body tube aside, and actually be another day or so before you get to that step anyway. So starting with the instructions, basically I've marked out all that doesn't apply. I do highly recommend this. The National Association of Rocketry is what I'm a member of. It's a great website. I would read that, although you don't have to be level 1 certification. You will be shooting engines that are well within the limit of what is considered NAR restriction for anything over level 1. But the precautions and the procedures they use I highly recommend for the safety of people who are around you shooting it. So pull that up and read that if you would, please. So the parts, I've marked out most of all the components that are basically to go inside the engine tube that we're not going to use, and some of the hardware that that we don't use on this kit. And so really the main pieces from the kit that you're going to use is the motor tube, that's here, the fin locks, the two fin locks, the plastic pieces, you'll see those. You'll have 3 centering rings, the fins obviously, the shock cord we'll use, the body tube, which I've already discussed, the launch lugs, the nose cone, the decal set, and the parachute. Now the launch lugs, my original kit had these on it. You can see them. So once you glue them on and you paint them, they kind of go around. That holds a 1/4 inch rod. So yes, you will use the launch lug, and please note the tapered end goes facing upwards towards the nose cone. The body tube is already perforated or punched out where these go. So when you take this out for the fins, you might go ahead and punch these out as well. There's one here and there's one here on the body tube. So I would go ahead and punch those out. Also file and clean those up, and do that before you do the putty. That way you won't get the putty anywhere near that. So sorry about missing that step. So let's start the assembly process. So the motor adapter section on the first page we're not doing. That's for other manufacturer engines and engines that don't use the CTI engine casing. So you'll have an actual cardboard tube you'll see in the kit with 2 smaller tubes. We're not using any of that, so disregard that. So moving on to page 2, again, the initial assemblies talk about putting the engine hook, which we're not going to do. So I have marked out all the pieces that we're not doing. Basically, do not attach the engine hook to this engine tube, nor put anything inside the tube. We want the tube completely clear of any obstructions. If you follow the directions, they'll have you gluing a donut ring inside, and if you glue that in, you cannot put the CTI engine in. So what I have here is I have the engine, the motor tube, and this is the CTI casing, and you can see how the flange here is bigger. That's what holds it in. That's why we don't need to glue all these pieces in per the kit, because you push this in, assuming this is in the rocket, you can see that bottoms out. This flange hits the end of the motor, and that's the connection point that basically takes the thrust from the engine casing into the rocket itself. So the retention ring that we'll put on actually then just goes over this and will hold this piece up against the motor casing. So that's why there's so many steps in this being deleted, because when you take this out, well, I don't know if you can see it. If you look in there, you can see, it goes about halfway up into this motor, and so if you glue those donuts in, you can't put this engine casing in, so you don't want that. Okay? So assuming you've done the sanding and you've done the putty on the body tube, the first step from the instructions that you begin to follow is under the section motor tube assembly on page 2, and you start with number 3, and I actually put an arrow. And basically what it's saying is use the location guide, make a mark along the motor tube line at 2 15/16 from the back end of the motor tube. This mark locates where the back edge of the front fin lock ring will be. Make another mark 7/8 inch from the back end of the motor tube. This mark locates where the front edge of the rearmost fin lock will go. So making these marks is important, so I'll show you how to do that. Okay, when you get the tube for the step 3, if there's not a line already on there, what I do is I use like a corner channel or something, like on this aluminum stock I've got here. It's a right angle aluminum stock, and basically I put the motor tube in there, and then I just draw a line down the length of the motor tube. So I have my line here, and then you can either use the guide that they're talking about up here. You can line up the back end of the tube here on the guide, and you can make your marks. I would caution, because my prints have been scanned, so the scale is not quite right. But I use a pair of calipers, doesn't matter. Case in point, the first one is 22 millimeters from the back end, which I made the mark, and then you make another mark at 75 millimeters, or 2 inches and 15/16. So that's step 3. Then we go to step 1 under the fin lock assembly, and it's key here, as I say, for the next steps all the way to step 5, do not use any adhesive. So this is all just pressure fitted. You want to get everything fitted and aligned before you start adding adhesive. So that's critical. So first of all, step 1, with their motor hook channels aligned with the motor hook, and again, in our case, we're not putting the hook on, so when they say the motor hook channel, I would just align that channel with the line that you drew on the tube. You'll notice the centering rings have a little cutout for the engine hook if you had it. The fin locks have a channel here, here, and here. Just make sure all of those line up with the line. One side lines up with the line you put on the tube. So again, it says with their motor lock channels lined in the motor hook, slide in the fin lock ring and then a aero fiber centering ring over the front end of the motor tube. Push on the centering until the back end of the fin lock rings is moved to the forwardmost mark made in step 3 above. Make the rings, note, the rings are designed to be a tight fit on the motor tube. If the rings are difficult to slide onto the motor tube, round the inside edges of the rings with sandpaper. If the fin lock rings need to be turned after they are on the motor tube, use a small piece of cloth to provide a better grip. Step 2, slide the other fin lock ring and then a centering over the back end of the motor tube. Push on the centering ring until the front edge of the centering ring is at the rearmost mark made in step 3. Using the line on the motor tube as a guide, gently twist back centering ring slightly until the fin locks of the back fin lock ring are aligned and the fin locks of the front fin lock ring. Okay, so all that said, and you end up with this configuration here. So you should see this fin lock lined up with the mark you made at 22 millimeters, and you should see this fin lock lined up with the line you'd made at 75, and you basically have the centering ring pushed flush up against the fin lock. Now, to know that your locks are done properly, in this next section they're going to have you snap in the fins. And so basically what you should see is that the fins should line up with these snap points, and the distance, the outside distance from both these rings should match the length of the fin lock itself. So the tab, let's see if I can, so this piece right here of the fin, that distance should equal the spacing of these two fin locks. Okay, and obviously you want them twisted where they align. So that's basically what they're doing here in step 4. They're making sure that everything is aligned before you start gluing these in place. So what it says here is, this is page 3, under the fin lock assembly continued. Test the proper positioning alignment of the fin lock rings by snapping the fins into the locks. If any fin does not snap into place, check to see that each fin lock ring is the correct distance from the back end of the motor tube and that the fin has no plastic flashing left over from the production that may be preventing a proper fit. Remove any plastic flashing with a hobby knife or sandpaper. After making any adjustments, carefully remove the fins and the back centering ring. Check that the front centering is still positioned next to and touching the front lock. So when you do a test fit, you have the centering ring, the back one, in place. And so the idea is when you snap the fins in, that tab, this tab here, should be snug between the two centering rings. One centering ring is here, one is here. Once that's all fit and everything's snug, take the rear centering ring off. We don't want to put that one on yet because we're going to use that access point to put adhesive on the body tube. So step 5 is where you start gluing. So you apply a bead of cement where the front centering ring meets the motor tube. Without getting cement in any of the fin locks, apply cement only to the areas between the fin locks where the front fin lock ring meets the front centering ring in the motor tube. Step 6. Without getting cement into any of the fin locks, apply cement only to the areas between the fin locks where only front edge of the back fin lock ring meets the motor tube. Do not apply cement to the back edge of the fin lock. Note, the unique AeroTech fin lock fin mounting system carries and distributes aerodynamic and thrust loads throughout an integrated rocket structure in a manner found in large aerospace vehicles. Loads are primarily borne by structural members and not cement. So, all that said, let me see if I can point this out. You basically want to put cement all in here, and you can put a lot because this is not going to be visible. This seam and this seam, just don't put anything where the locks are. So you want to go 3 points around. On the other side, you want to put a lot of cement from where the centering ring touches the motor tube. So you want to go all the way around there. On this side, you only want to put cement on this side of this ring, the lower ring, because we haven't put the centering ring on yet, and you don't want to put the adhesive in this area until you're ready to put the ring on. But you put plenty of cement here on this side. So 3 surfaces you're putting cement, and you can put a lot on there. So use the epoxy for that. Okay. So once that's done, you're basically putting this part aside for a full 24 hours and letting it dry. So at this point, you're taking a break. You've got the body tube with the putty on it drying, and you've got this assembly. It should look just like this without the motor hook. This is drying, and even though it's 5 minutes, I'd let it dry at least 12 hours before you start handling this anymore. So that concludes the first day of assembly.